Good morning, everybody. Eamon here. I'm going to answer our first Quechua member Facebook group question, which is from Ian Jones. I'm going to read it verbatim so I don't get it wrong. Eamon, is quantum computing a practical proposition within the next 5 years? And please explain what evidence you can cite for your viewpoint. What a great question. Good on you, Ian. Great question. Practical proposition, what do you mean by that? Do you mean that we'll be doing banking with it and that the quantum cloud, quantum internet will be fully functional? Because all of those things within 5 years is a big zero. It took the digital, going back to ENIAC, which was 1945, so that's 80 years to get to where it is now. And quantum computers have only really been going since the mid-80s with Richard Feynman, and even at that stage it was extremely theoretical. So 5 years is the wrong amount, but if you increase that, and not by a huge amount, probably 10 to 15 years, I think there's a much greater chance that we will be making practical use of it by then. We'll certainly be enormous way there. You asked me for evidence. The first evidence I would give, of course, is the Google and NASA claim of quantum supremacy just last month. Now, I've written on this, and basically Google exaggerated their claim, and they said they could do in 200 seconds what a digital supercomputer would take 10,000 years to do. So IBM, a little bit miffed, IBM tweaked their digital computer and came up with the answer in 2 days. But you're still comparing 200 seconds with 2 days. IBM said they can do better. It's all, can my mum fight your mum? It's not the point. We're losing the plot. The point is, a quantum computer, in this case, it was a 53 qubit quantum, it's on a Sycamore chip, and it actually mapped out 4 quadrillion states at the same time. Wow. So it's up there with digital computers already, maybe just for meaningless tasks at the moment, but that's how it all starts. It's a bit like saying when the Wright brothers flew Kitty Hawk, it was meaningless because they didn't take off and land at an airport. It's, the fact that the task was meaningless is irrelevant. There's no question that the industry is going to bloom and blossom, and we're going to need quantum knowledgeable people. The reason for Quechua is to engender that desire in many people in WA. The course I'm writing on quantum computing, which will be finished just before Christmas, is, to my knowledge, the only non-university related course in the whole of Australia. And I'm doing it very diligently. It's going to be a good comprehensive course that will take you to step 1. And to any Quechua Facebook member, it's free. So, it's a really good question, and I don't want to be one of these, you get a dichotomy of opinion. You get some people saying we'll never, ever do it. Well, that's been poo-pooed, because with Google, NASA's experiment, it's certainly functional. And then you'll get the other people saying, the world will be ruled within 5 minutes by quantum computers. And like anything in life, the truth is somewhere in between. One thing I would say is you just have to understand how difficult it is to build a quantum computer. If it was easy, they'd have done it by now. The quantum computers are based on the atomic level. In fact, what's happened, the silicon chip, you can't fit any more integrated circuits on the silicon chip anymore. Without it, because they're down to 7 nanometers between the integrated circuits. And the point is, quantum physics, a thing called quantum tunneling, comes into vogue at that level. So digital computers are not going to get any better very soon. Moore's law, where they were doubling in power and halving in price, Moore's law has now reached its zenith, if you like, or is very close to it, simply because quantum physics and the quantum phenomena of quantum tunneling means that you can't, what happens with a digital computer is the electron's either there or it isn't. And now, because, so the door's open and lets it out, or a door opens and lets it in, a gate. And what's happening is the electron is using quantum tunneling and going through the gate anyway, which means that the calculations are being falsified. And the big problem with quantum computers is that it is at an atomic level, and any change in heat or even just normal environmental disturbance changes it. It's exceptionally sensitive. The actual qubit, which is a quantum bit, has to be as near to absolute freezing point as it can be. If you want a quiz question, you can ask, what's the coldest place in the universe? And it's not out in these millions and billions and billions and billions of miles away from any galaxy and any thermal radiation. It's actually at the bottom of what's called a dilution refrigerator, is where you get your qubit, because they need to stop the heat. Is just the electrons jiggling around, and they need to stop that. And this is called quantum interference, and that's the big problem. By the way, quantum computers are already being used now by Alibaba, Google, Microsoft, IBM. There's a number of them, but they're quite inaccurate, if you like. So it's making approximations, and in some cases where you don't have to be exact to the 0.00001, it's being very, very useful. But a true quantum computer, which will probably have to be on a particle called a Majorana fermion. A fermion just means a bit of matter. And the Majorana fermion, which was actually proposed by a guy called Ettore Majorana back in the 1930s, and he went on holiday and he went missing. A lot of people believe he was kidnapped, but that's another story and another bit of goss. But the Majorana fermion is a particle that exists with its own antiparticle, which means that nothing can interfere with it. So if we could somehow get the qubit onto a Majorana fermion, there would be absolutely no interference, and it would be true quantum processing. And the quantum processing is exponential, as I say. What does this mean? Well, it means if you put 300 qubits on the one chip, entangle 300 qubits, that means it can map out the same amount of atoms there are in the universe. We're going to do it one day. Thanks for the question, Ian, and please, Quecqua members, please ask me a question and I'll answer it within 48 hours. Thank you very much.